we'll continue where we left off. The second implementation of the Jack's walking include a loop and two if statements. So for Jack, if you look into methods, he has something interesting here. Here itself, he has something called walk how far under the methods. See, typically for most objects, these are the methods you will see. In addition, the moving, that's how it starts. But for Jack alone, he has this extra methods. What that means is they have some extra methods they implemented specifically for Jack that we can use. Okay, so what we are going to do is just go ahead and delete this method, our move forward. I'm just going to drag this walk and put it there and walk 0.5 meters. So we're passing a point, some argument we call it. So this existing method, unlike the other methods, so this guy is accepting the one parameter, so how far he should walk. Okay, so let's play this. Wow, amazing, isn't it? I mean, that's a very sophisticated walk. So instead of just gliding earlier, so now he is really doing real walking, right? So that's pretty good, very impressive, right? So let's see, he does look like he turned away. You can see that he's walking away from the destination. That's because of some Alice bug. Let's see, play again. It's nothing to do with our program, okay, our code. So time to time I have seen such errors too. So usually if you quit Alice and come back and try to do it, sometimes it fixes, or even just to close the playing and restart the playing, it will work. But it's generally better to shut down the Alice tool completely and restart it. Okay, then the problems seem to disappear. Okay, so I hope you kind of understood this existing methods, so how these existing methods work. In fact, it's possible to really change this very differently. So see, let's look into this again, this picture. So instead of walking little bit at a time, you can also walk the distance. You can specify higher distance. You don't need this loop. You can simply walk all the way to the end and come back. Okay. So I'll just show you one version. We will come back to this version and continue, but I just want to show you one more version. Let me see. Just going to save this one. Okay, so I want to show you another version where since this guy does accept how far to walk, so we don't even need this complexity if we really want to take advantage of it. So from here you can say turn, make him turn, and simply walk this distance fully, then walk this distance fully, so on. Okay, so let me get rid of all this stuff. Maybe I'll just leave this one as it is. Okay, so now let's see, just put a number. I hope you kind of getting the idea. So let's see, 2. So how will this work? Or in fact, you can be even put more. Yeah, that's okay. Let's see how it works. So it's turning to face the tube, then go to the loop, walks to 2 meters, and turn to face the cone and walk 2 meters, then turn to face tube again. Let's see. Okay, So he's kind of walking back and forth, just that he's not going near the end objects, right? Okay, so how can we fix that? Instead of 2, can we say something else? Let's see. Jack functions Jack distance to. Okay, so let's see whether this Jack's distance to helps. Jack's distance to tube. So we want Jack to walk distance to tube. So once Jack is here, we can say Jack distance to cone. Okay, so Jack turn to face the tube, then walk all the way the distance to the tube, then turn around to face the cone, and then walk that distance to the cone and turn around again. Wow, he's going fast. Okay, he is kind of sliding. Anyway, so you can see he's going exactly onto the tube and onto the cone. So okay, so we don't want him to do that, right? Okay, let's see, we can adjust something, the distance little bit less. Expression math minus 0.5. okay, so here also the distance to the end object, then we want to do, I want to show you the expression. So right click, express math minus, so Jack distance to the cone minus 0.5. okay, so now let's see how it looks. Okay, he stops short of that object reasonably at reasonable distance, right? So it doesn't go and step on the object. Again, this is another version. I'm not planning to build on this version. I just wanted to show you can take advantage of existing methods. So some objects do come with the existing sophisticated methods in addition to the standard methods that come with the objects. Okay, so if you can take advantage of them, and you can do the job a lot easier way. Okay, so you can see he's moving a little bit funny movements now and then. It's kind of self-correcting again. Okay, so going back again, Jack is turning to face the tube, then he walks towards the tube all the distance, comes pretty close to the tube, then turn towards the cone, and he walks all the way. Using this method, we specify how much distance to walk, then turn towards the tube again and goes to the top and continues. Okay, so in a sense the inner while loop has been replaced by this method, by specifying the lot higher value for the distance. Okay, instead of 0.5 we specify the full distance. That way he's completing the full one direction walk. Okay, so then the next tutorial I will go back to the previous version of the program and try to do walking on our own. Okay, sophisticated walking on our own.